So let's try to finish up. So yesterday we did the arc measure, right? The measure of an arc in degrees, correct? So now we're doing the length of the arc, how long the arc actually is. Not how many degrees it is, not what angle it makes or anything like that, but we're finding the actual length of an arc. Well, let's start off with a circle. Let me find a circle. There we go. All right, so there's a circle. Let me put the center. I should have a circle with the center already made, so I don't have to do this every time. But anyway, there you go. And let's just talk about this. Let's put a little thing right there. What is that I just drew? It's the radius, okay? So that's the radius of the circle. So what we're going to try to do is we're going to try to find the length of an arc. Let's just put it here, okay? So if this one right here, this straight line right here is a radius, what is this straight line right here? It's also the radius, the same exact measure. Would you agree? So let's say this is, it's a little steep for this, but that's okay. Let's just say it's 60 degrees, okay? It's probably closer to 80 degrees, but in my notes I put 60, so let's stick with 60. What we want to do is we want to find the length of the arc. So let's draw a little picture where that arc is. So that, it's a little wiggly, but that's okay. That right there is the length of the arc. We're not trying to find the measure. We know the measure already. So what's the measure of that arc? It's 60 degrees, because whatever the interior or the central angle is, then the arc is the same measure. Okay, Zion, you getting all this? Come on, take some notes. No, just because you can repeat what I said doesn't mean you're really paying attention. All right, head up, eyes up. Let's take a look at what we're doing here, because you're going to need to know this. So let's talk about not just the arc. Let's talk about the length around the whole entire circle. So tell me what you know. What do you know about the length or the distance around a circle? Give me a word. It's the circumference. Exactly right. All right, so let's write that down. Circumference. Circumference. Did I write that? Did I spell that right? Yep. All right, so the circumference of a circle. We use C for circumference. There's a formula. I don't know. Have we done that formula this year? I can't remember. I think we have, haven't we? Yeah. You could go pi times diameter, or since we're dealing with radius here, let's call it what? 2 pi r. All right. So yeah, I do remember now doing this stuff. So that's something you should have memorized. What does that mean? What am I saying? If I said find the circumference of this circle, and let's say the radius is 9. Everybody's paying attention, right? I may not do all that little stuff that we did before, show you pictures and all that kind of stuff, because it doesn't seem like you can handle the transition from looking at stuff that has nothing to do with math and then going into math, all right? So maybe we'll just start doing math right away, because it just seems like there's too much silliness going on. All right, enough of that. Let's talk about the circumference of the circle. What am I finding? Let's actually find it. The radius, I told you the radius is 9, so let's find the circumference of this circle, which means the distance around the whole entire circle. If I was to walk, if I started here and I was to walk around the circle, how far, not how many degrees, but how far the length would I walk? Okay, that's what circumference is. You understand that? So here we go. What is it? It's 2 pi what? R, which is 9. All right, let's do some math here. What do we get? 18. Yeah, and we're just going to keep it 18 pi. All right. We could, if we wanted to, do what? Put it into a calculator, put 3.14. All right, we could do that and it'd be fine. But right now, I'm fine just keeping it 18 pi. You're going to find out later, really not in this class, but probably not, next year in Algebra 2. Depends on how fast you go, but if you do a little bit of trig stuff, you're going to be doing a lot of stuff in terms of pi. It's called a unit circle. It has a little bit to do with what we're doing in here, but you're going to measure things in terms of pi. Instead of degrees, okay, you're going to measure it in pi. So with that said, let's do this. So how far did we go? We went 18 times 3.14, whatever that number is, and I don't really care what that number is. So that's the circumference. That's the distance around the whole entire circle. But what are we trying to find? We're trying to find the distance just around the what? The arc, the blue arc right here. Okay, that's what we're trying to find. So we're not, oh, you kidding me? If they would have told me that, I wouldn't have told all those stories at the beginning. All right, well, let's pause. It's a nice day, so we can have a nice, where's my pause button? There it is. Okay, let's pause. All right, let's keep going. Had a nice little fire drill break. So let's talk about this real quick, because we got a lot to do in just a handful of minutes. So to go around the whole entire circle to be 18 pi, what do you think you would do to go around this much of the circle? Like, how much of the circle are we going around?
18 pi minus something.
Minus something? Yeah, that's true, but, well, that would be to find like this, right? We want to find the something. So how much of the circle is this? How many degrees is the whole entire circle? 360. How many degrees are we finding? Are we going around the circle? We're only going 60 degrees out of the whole circle, right? So what do you think we're going to do? 300? I'm only trying to find the blue. 60 over 360, right? We're going 60 over 360, not 300. That would be this arc right here, okay? So we're just doing this blue one. So that's only 60 degrees out of the entire 360 degrees. So it's that part of the circle. What does that reduce to? You can do that in your head. The zeros go. It's just simplifying fractions. 1 over 6. So we're going 1/6 around the whole entire circle, correct? So we're going 1/6 of what? 18 pi. That's right. Would you agree? And do the math. 6 is on the bottom, 18 on the top. That goes once. That goes what? 3 times. What do we got? 3 pi. So how far did we go from here to here? We went 3 pi. It's not a straight line. Remember, it's a curve. All right, that's where the pi comes in. All right, so it's around a curve. It's not just a straight line. So it's 3 times 3.14. So it's a little more than 9, right? So would you agree that that makes sense? If this is 9, this is 60 degrees. Yeah, we're not going to get into that. Was it in here? Yeah, we did 30, 60, 90 triangles, didn't we? Yeah, we're not going to talk about that right now, though. So there you go. So that's how you do it. So we could come up with a little formula. Let's come up with a little formula. We'll use L for the length of the arc. Okay, we're finding out how long it is. What's the distance from here around the circle to here? That's the length, L for length. Everybody got it? So L is the length of the arc. So what do? We take our central angle and we divide it by what? 360. What are we going to call that central angle? Is it always going to be 60?
Theta.
Yeah, we'll call it theta. Very good. Okay, so we're going to call it theta. We've talked about that, haven't we? Did we do that before? Oh, yeah, to do the central angle thing. Yeah. All right, so this is the portion of the circle that we're going around. Yeah? So this is the portion. That in this case, it came out to 1/6. But then what are we going to do after this? We're going to multiply it by what? We did 18 pi, but where did we get 18 pi? 2 pi r, the circumference. You could just put c. In fact, I think the book does put c for circumference. Or you could just put what? 2 pi r. Okay? So that right there, it's not like you have to absolutely memorize that little formula because we already kind of figured out where that formula came from. We kind of developed that formula on our own, didn't we? Because we said, okay, we're going 60 degrees out of the 360. Okay, there's your theta over 360. Okay, times the whole entire circumference, the 2 pi r. We already knew that. So really there was nothing in there that we didn't know. We just kind of put a couple things together. That's all we did right there. All right? So that's a theorem. It's in your book. That's the length of the arc of a circle. So that L represents the length. Let's write it down. The length of the arc. Again, we're not finding, this is not the degree measure of the arc. Okay, this is not the measure of the arc. When we say the measure of the arc, we measure that in degrees. When it says the length of the arc, that's measured in whatever the units are. Now, I didn't put any units here, but you could put like maybe centimeters, okay? So this would be what? 3 pi centimeters. It's not squared because we're not finding the what? Area. We're just finding the length, the distance, okay? So it's just centimeters or inches or feet or miles or whatever they give you. Everybody good with that? All right, let's do a couple examples. Let's do this. Let's copy that, make it a little easier. This is basically, what we're going to do right here is basically the same thing, except for one of them. One of them is a little different, okay? This one's kind of easy. The first one is. You know what I'm going to do? I'm going to copy that, and then I can paste it, and I already got the dot in the middle. Okay, so we're going to make this really easy. We're going to go from there to there, and we're going to go from here to here, and those two radii are perpendicular to each other, so that's a right angle. And the length of the radius is 10, and they put yards, so it's 10 yards. What I want you to do is I want you to find the length of the arc. And again, let's use the color. We're trying to find the length of the arc between those two radii. Okay? So I want to find the length of that. Oops. There we go. So I want to find the length. So how do I find the length? You could memorize the formula, but what are we going to do? We're going to do a portion. This green is a portion. It's a part of the whole entire circle, correct? So how much of the whole entire circle is that green part? Well, it's 90 out of what? No, not 180. What did we just write down? 360. It's out of the whole circle is 360. So it's 90 out of 360, which if you could do this in your head, what's 90 out of 90 over 360? It's 1/4. It's 1/4 of the circle. Does that make sense? Yeah, if this is 90 degrees, there's 4 of these 90 degrees, aren't there? Right? There's one here, there'd be one here, here, and here. So that makes sense. It's 1/4 of the circle. So what is a circle? A circle, or the circumference of the circle. What's the length around the whole entire circle? 2 pi what? R. In this case, what is our R? It's 10. And now you just do this. All right? So this is 1/4. I'll just do it kind of an easy way, I guess. 2 times 10 is what? 20 pi, correct? Put it over 1. This one works out nice and easy. They don't always work out this nice and easy. Sometimes you might need a calculator. So, but this 4 goes into this 20. 5 times, what is it? It's 5 pi. All right? And it's in yards, so it's 5 pi what? Yards. Okay? Simple as that. Now, you could, if you wanted to, you could make that 3.14, multiply it by 5. If you did, it would be approximately 15.7. All right, so that's how long it would be to go around a quarter of a circle that has a diameter of 10. All right, it's about 15.7. About. Why did I make that squiggly? Because this 15.7 is what? Is an exact answer? No, it's an what? It's an approximate answer. That's right. So we can do that. Now, if I don't tell you to make it a decimal or anything like that, you can just keep it 5 pi. It's perfectly fine. All right? Or if you wanted to, you could change it, put it into a calculator and do that. But the problem with doing this, if I don't ask you to make it a decimal answer, if I don't ask you to do that, that's just one extra step that you don't have to do. Would you agree? And it's another step that you possibly could make a mistake, right? I mean, like Mr. Hemrick, I'm using a calculator. How can I make a mistake? Well, you can very easily punch in wrong numbers. I've seen it all the time by students, okay? I do it myself. So just keep it 5 pi. That's how I would keep it. All right, and there you go. All right, this one's a little trickier. This one's not as straightforward, but let's see if we can do it. Come on. There we go. Oops, what happened to my dot? All right, let's put my center right there. There we go. And let's copy that again. I don't know what happened there. I think I know. All right, let's do this. Let's do a couple radii. One right there and then one right there. And I am going to tell you the radius. Yep. I'm going to tell you the radius, which is 15 inches. 15 inches. And I'm going to tell you the length of the arc. So this is a little different. All right. And again, we've been doing this in another color. So let's go ahead and do that again. And I make it kind of thick. So they tell you this. They're not asking for that. They tell you that. And they tell you that that's 5 pi. 5 pi. What do you think they're going to ask you for? The central angle. Exactly right. Okay, so they're going to ask for this. And we call the angle theta. That's what they're going to ask for. Well, if you know the formula, it's at least a good start. So do you remember the formula? The length is equal to what? Theta over 360 times what? 2 pi r. Remember that? Okay. So what do we have to do, though? We have to solve now for what? Not the length, because they tell you the length. We got to solve for theta. Everybody okay with the beginning of it anyway? So what do? Let's plug some numbers in. Let's plug in what we know. Do we know L? We do. What is it? It's 5 pi. Right. So let's put in 5 pi equals, we don't know theta, so I'll keep it theta, over 360. And we could figure out 2 pi r, can't we? Let's do that off to the side. So what is that? It's 2 pi, what's r? 15. Simplify that. What's that? 30 pi. All right, so let's put that right there. And I'm going to put it on top, 30 pi. Just put it over 1. Is that all right? You don't actually, you don't need to do that. But yeah, let's do it anyway. So let's see. What can we do? How do we solve for theta? So now it's algebra. Our geometry is over. All we got to do is figure out how our algebra works. So I got to solve for that. That's my variable. Well, I got to get rid of all the stuff with the theta, don't I? So let's do this. Let's simplify a little bit. Look at the 30 and the 360. What can happen here? Well, the zeros cancel, right? Then 3 goes into this once. 3 goes into this what? 12, yes? All right, let's clean it up a little bit. You could go from there, but since this is our first time doing this, we'll just clean it up. And then it's times what? That all canceled on the top, so what do I have here? Just a pi. Yes? Now look what I can do. I got a pi here and a pi here. It's the same thing on both sides, and they're being multiplied. What can I do with both of those? If it's being multiplied, what do? I divide. That's right. So divide both sides by pi. So what will happen with the pi's? They cancel out. So if I divide this side by pi, divide this side by pi, they cancel out. Yes? I'm going to write it down again just to make it nice and pretty. You could have done all this up at this step up here, but I'm just trying to make it a little easier for you. Now, we got one more step and we're done. How do I get theta by itself? It's being divided. How do I get rid of something that's being divided? I multiply. Right, multiply by 12, multiply by 12. So what is that? It's 60. It's an angle because it's theta, so it's what? 60 degrees, and that's my central angle right there. That's how you do that kind of stuff. Oh my gosh, we still didn't finish this. Try to do as many as you can. What is it, 2 to 16? Yeah. You should have already been able to do 2 to 8, so now you should be able to do a few more. I don't think you're going to be able to do all of them. Maybe a few at the end you might not be able to do. We'll try to finish up that tomorrow. Sorry about that. So do 2 to 16 from section 8.3, section 8.3. And then hopefully we'll be able to finish it up tomorrow. No more messing around tomorrow. We're going to get right into it as soon as we get in here.